Welcome to the Digital Amateur Television Experimenters Night. This is VK7OTC, the club station of the Radio and Electronics Association of Southern Tasmania. Amateur radio is a worldwide hobby that has many different aspects. Digital television is just one of the many modes and areas that are covered. Maybe you're interested in becoming involved in the DATV Experimenters Nights. You realise that you do not have to be a radio amateur or need any ATV equipment to participate anywhere in the world. Also participate in the night by coming up to the Queens Domain Clubrooms. Yes, right on top of the Queens Domain in the heritage-listed Coast Wireless Station. You never know, we might get you in front of the camera or behind doing one of the many roles during the night. We get underway with our program on a Wednesday night from 7:30 p.m. local time. We'll see you soon. This is VK7OTC.
Okay, this is VK7HSE, the club station of the Radio and Electronics Association of Southern Tasmania with our DATV Experimenters Night. Coming to you from Mast up Southern Tasmania, and we've, as you probably heard, and experienced, we went into a bit of a snap lockdown for 3 days, and we've got masks in place for up until 6 o'clock on Friday. Hopefully, fingers crossed. So, tonight we've got a continuation of our resonance series, and I've actually found so much material that we're probably not going to get to the RF resonance element of the presentation, so I might actually leave that until next week. So we've got lots of things and continuing things on mechanical resonance and some examples. And also we're going to try a bit of a reprise of the Chladni plate that I've got set up here in the studio with much finer, almost dust particles, because I have a feeling we might be able to get some three-dimensional type effects with the dust, the actual salt dust. I've crushed up some salt, but anyway, we'll try that a little bit later. I haven't actually tried that at home, so you're going to see the results right here on live television, live stream television. I'm looking at the YouTube chat channel. Please call in if you're watching from the chat channel. Let me know you're out there. Let me know where you're coming in from, and of course any questions as we go through. Now, as a bit of a reprise, one of the things that started me on the resonance pathway was I have a discone antenna for VHF and above that is sitting up on top of a pole above our television antenna, and it's connected to a plumbing vent pipe, which is a metal pipe. It's a galvanised iron pipe, and when the wind is the right speed and also from the right direction, obviously, this discone antenna resonates, and just as a bit of a so that's it. resonating in the wind at home. Now, as I mentioned last time, I find this absolutely fascinating and a very there we go. And happy to listen to this, but the rest of the family doesn't share my passion. That's probably a good way of putting it. But what it got me thinking about was what is resonance, some other examples of resonance, and of course the importance of resonance in radio frequency. So we've got some examples. We're continuing with our mechanical resonance examples tonight. Now, just to remind people, what is resonance? It's the phenomenon of increased amplitude that occurs when a frequency of a periodically applied force is equal to or close to the natural frequency of that system upon which it acts. So when an oscillating force is applied at a resonant frequency of a dynamic system, the system will oscillate at a higher amplitude. So it actually, like the sound of the discone resonating, suddenly you get a sound, a quite pronounced and higher amplitude sound. Oh, and hello from Steve VK700, who's up in VK2. G'day, Steve. So that's what resonance is all about. And it's interesting, after our program last week, Tony VK7LOR, Lima Oscar Romeo, from down near Dover, actually said that he had some interesting examples of resonance. And he talks about in 2013, whilst living aboard my yacht in a channel near Stieglitz in Queensland, between the hours of 1500 and 2100, so 3 o'clock to 9 o'clock at night, the rigging on my 30-footer resonated with harmonics changing the tone in a repeating pattern. And it was only between 1300, so 3 o'clock and 9 o'clock, and it was very audible. And his guess was that the rigging was responding to machinery in a sugar mill that was about 5 kilometres away. So it shows you don't necessarily need close proximity for there to be resonance set up. And he said, and this was a daily occurrence, and at 2100 the sound stopped instantly. Obviously, when the machinery stopped at the sugar mill. So there. And the other one he talked about was well, my banjo it sits in a stand, and when I speak or sneeze, the banjo rings in sympathy to the sound generated by me. And I've prevented this by hanging a bandana over the fretboard, which dampens the strings. Now, this reminded me of there are a number of instruments that use this effect. To good effect, I have to say, to good effect. One of them is what we call the Aeolian harp. Now, the Aeolian harp is, and what I'll do is go to the PC. Now, the Aeolian harp, here's one here, and I'll just click on this to show you. This is, it looks very much like a harp or a guitar. It's got a whole lot of pegs here that you can tune the strings to. All the strings are in line underneath here. And there is a slot that goes all the way through. It's open on this side and it's open on this side. And what you usually do is put this into open a window and put this into the gap that's in the window. So the air has to be forced over these strings that are all tuned, usually what they call pentatonically. And pentatonic tuning is tuning that it means that any note will mix with any other note, and it'll sound to our ears like it's a harmonic. Those notes go together. So pentatonic, a good example of pentatonic tuning is if you were to push all of the black keys on a piano, all of the black keys are pentatonically tuned, and pentatonic just means they're a fifth apart. So, so this is an Aeolian harp. So you put this in the window, the wind comes in through the gap in the window, and it plays tunes, and it plays tunes based on the wind, and the wind is the energy that is being inputted into this system, and each of these strings is tuned differently, and so it plays I suppose a natural tune on the Aeolian harp. So that's one of the interesting little nuances of resonance. Those strings are resonant. The energy that is inputted into the system to get them to resonate is the wind, and they all sort of resonate together. Now, another interesting little effect is and I'll just see whether I can get to. Here we go. I think it's now. There's a thing called, and actually before we go on to that, there was another there we go. Now, the way that this actually works is there is the string is if you like if you look at a string in plan, so if you cut through a string, it's this round object that the wind hits, and because of the shape of that object, the energy that the wind provides goes over the top of that string, and what you get is this effect, which is the Kármán vortex street effect, which is a repeating pattern of vortices. This is actually the pattern, if you like. There's a circle here. There's a stream of smoke that they have pushed in here with energy, and as it goes past this round item, you can see these vortices are created offset, increasingly offset as the smoke gets pushed further in this direction. And this effect, this Kármán's vortex street effect, is what creates the resonance, if you like, of the string. And if the string is also starting to resonate itself, it sets up these vortices, which then affect the other strings, because all the strings are next to each other. And so it sets up resonances in the other strings, and they start resonating and providing the sound, the pitch of that, how that string's particularly tuned, and it affects each of those strings, and they all literally play together. And this is the effect that's actually that's happening in an Aeolian harp. So absolutely fascinating. Now, this effect, it's interesting, this effect, because Rex and I went up to Launceston a long while ago now, but it was the first 10 gig contact that Rex did across Bass Strait, and we took a little step ladder with us, and the step ladder was tied to the top of the vehicle on the roof racks, and every so often when Rex would get up to a particular speed, the air going through the rungs of the ladder in this Kármán vortex street effect would set up a resonance. You'd get this hum that would start to appear. Just when you get to a particular speed, the air over those rungs would set up this resonance. And I'm sure there are some tradies out there who have ladders on their vehicles who probably experienced this effect and gone, bloody ladder. on top of the vehicle. But and it's also the same effect that you get with singing telegraph lines. Long lines that go across the countryside, you get the same sort of effect where they start to resonate and they start to sing, and that's why they're called singing telephone or power lines. So so very interesting. And we were Rex was certainly successful with David VK3HZ on that particular contact across Bass Strait, and that was the first 10 gig contact across Bass Strait. There was there's actually a video on the YouTube channel around that. So so there you go. Now, the other thing that this reminded me of is there are particular instruments that have what's called sympathetic strings on them. So, and a good example of that is what they call a hardanger fiddle. Now, you'll notice this is a normal fiddle that has the 4 strings. You can see these 4 strings here, 1, 2, 3, 4. But you'll notice running between the bridge here is 3 or 4 what they call sympathetic strings. Now, they are tuned to the same, either the same frequency as these strings, or they're tuned like an octave higher or an octave lower. And what happens is when you play these strings, the main strings on the fiddle, these strings start to resonate and give a very characteristic sound, because it's not only the normal strings that are resonating and vibrating at the frequency when they're struck with the bow, but it's also these sympathetic strings are vibrating and resonating and adding to the sound of these other strings. So there are a whole range of instruments that have sympathetic strings. We've got the hardanger fiddle, which I just showed then. We've got the sitar range, or the Sengeli range of instruments. So these come out of India and Central Asia. They have a whole lot of strings that are played, you can see here, by a bow, but sitting underneath them is a whole lot of other strings which are all tuned as well to different tunings, which give a really characteristic sound to Indian music and the sitar music. And you can see instruments with sympathetic strings, there are a huge number of them. There's guitars, there are cellos, there are the sitar range, there's the 10-string guitar, etc., etc. So there's a whole lot of instruments that are all using this resonance. The strings on the instrument are using resonance by their very nature. That's how they get. They're either struck, which is the energy, or they're bowed in a violin or a cello or a double bass. But in the case of sympathetic strings, they actually add strings that then also resonate when the main string's actually resonating. So, as people probably know, my wife plays harps and cello and piano. And on the harp, I went in and I thought, I'm going to test this theory. So I played an A string, which is for the center A440 string, 440 hertz, and that causes the E string. Now, and the E string is specifically it's at 330 hertz. So, and I was able to actually feel the E string resonating because I damped it when I put my finger on it when I was playing the A string. So, so it sets up these resonances. And pianos do exactly the same thing. As you play pianos, they all of the strings that are tuned in a harmonic of that particular string that you're playing is also resonating and providing the characteristic sound of that particular instrument. So resonance, lots of things rely on it. So so yeah, absolutely fantastic. And for our RF viewers, after this session, I've got a whole lot of videos on resonance and also sympathetic resonance and some of the demonstrations. And one of the demonstrations, the very first one, is by Professor Sumner Miller, Julius Sumner Miller, and he has an inimitable way of doing these experiments. I absolutely love watching Professor Julius Sumner Miller. He just has a way of putting these wonderful, wonderful things. So that's for our resonant viewers. Now, our Chladni Plate demonstration that we had last week, what we've got, and this is the plate so you can remember it, we've got a speaker which has a lid glued to it, epoxied to it, and then there is a shaft, a metal shaft that goes up to a metal plate, goes through a little bush. There's a plastic bush that it goes through that makes sure that all of the energy is in an up and down movement. So the vibrations is only up and down at the centre of the plate. And then you've got, what I've got next to it is it's ground up salt, so it's really, really fine material. And last week when we did the Chladni Plate, there were some interesting little areas and antinodes and nodes where all of the dust from the salt actually came together, and I was actually seeing a cloud in 3D that was actually not just flat on the plate, but it was actually a cloud that was off the plate. And so I thought, what I'm going to do is grind up a whole lot of salt into really fine dust, and we'll do the Chladni Plate experiment again, and we'll see whether we can get this get the effect in 3D. So what I'll do, we'll go to the plate and bring the now let's turn on now with our first, actually we might start from, we'll start from our lowest frequency. Got a bit of a dodgy connection with the oscillator. That's better. Okay. So we've got much finer, much finer starting to get some excitation. It's interesting, it's a different frequency. It's a different frequency to what we had last time. So the finer materials change the characteristics. Now we're starting to get that effect that you can see. Absolutely fascinating. They actually rise out of the plate. that off and we'll go up a little bit. Now the really fine material, you can see, those clouds that reappear. Real clouds. Side on, you can see those clouds rising up probably 3 or 4 millimeters. Okay, I think that's enough playing. But one of the key things I think we can glean from this is the difference with the particle size and the vibrations on the plate, totally different characteristics. So just absolutely fascinating. So that's the Chladni plate. So next week we will get on to RF resonance, which will involve inductors and capacitors and crystals and all sorts of things, and the use of resonance in radio frequencies. So we should certainly get underway. We've got a few experiments with grid dip oscillators to actually demonstrate where circuits are resonant and how they change and all of that sort of thing. So RF resonance next week, so really important. So now I wanted to do was I showed a couple of ATV nights ago the little Minikits filter boards, filter PCBs that they sell. Mark Kilmeyer over in Minikits in South Australia in VK5, and I've actually built up a couple of those filter kits as low pass filters, which for 630 meters. As people know, I play with and experiment on 630 meters quite a bit, and one of the things that you find on 630 meters is the AM broadcast stations. You do need to filter out the amount of energy, the amount of energy that they are, especially in capital cities, because the amount of energy that they put into the spectrum is quite phenomenal. What I've done, this shows you. This actually shows you the one of these little kits. You can buy the PCB kit, the actual 500 kilohertz low pass filter kit, and you can buy a case for it. This is the case, the Hammond case that it fits into, and it comes with two B and C connectors. You can see this has a couple of links where there are no components in that particular part of the circuit, because it actually is made up so that you can do, I think, up to a 9-order filter, a ninth order filter. In this case, it's a 5th order low pass filter. You can see there's a capacitor, capacitor, and then there's 4 inductors. This one and this one are the same value, and this one has an extra turn on it. And you can see I've connected in the B and C connectors in, and it sits very nicely on little standoffs in the case. So what I thought I'd do is show you, and this is the upper power limit of these is about 10 watts. So what I thought I'd do is actually we've had the Nano VNA on here before for a couple of experiments, and what I thought I would actually do is sweep this particular filter to show you that it is actually working in the area that we want it to work in. Now I won't go through the I won't go through the process of doing the calibration and all of this sort of stuff. I'll just set it up so that you actually see the display, the format. We want log magnitude. We want the log magnitude, and we want the scale. No, don't need to change any there. With the stimulus, which is the frequency. So the start frequency, what we'll do, we'll start at, I don't know, 100 kilohertz and finish at megahertz. That's probably a good way of doing this. And we'll connect up. Okay, now let's turn off the other traces there. Back, display, trace, turn off. Now, so what we've got here is the Nano VNA doing a log magnitude through. Oh, now the other. Now, hang on. The other setting is I want a band pass, and I want the channel through. Okay, so what we're seeing here is the log magnitude of, on this side we've got 100 kilohertz, on this side we've got megahertz, and you can see it quite quickly drops off, and if we move the gradical, you can see down here, we move it up, we're going down in frequency, we're going down in frequency, we're going down in frequency, and we get to that knee there, and it's about 460 megahertz, 460 kilohertz, sorry, 0.46 megahertz. So there you go. So this starts to drop off at, and we're to give you a reference, this is at minus 4.42 dB at that sort of level, and then we drop off quite quickly. We're at 505 kilohertz, and we're at minus 16. So we keep going, 5, we get to 600, here we go, 604 kilohertz, we're at minus, oh, what's that say? I can't read it. Minus 43 dB. So you can see this is cutting off everything above about 460 kilohertz, and which is great. Starts to because the area that we're operating is about 470, so fantastic. That's doing exactly what we want it to actually do, cutting off everything above 500 kilohertz. So this is one of those little Minikit EME. Hang on, I can tell you the number. EME 164 kits. Now it doesn't necessarily need to be a low pass filter. It can be a high pass filter, it can be a band pass filter, it can be whatever you want to actually configure it for. So that's the Minikits EME 164 little filter boards that you can basically configure to whatever configuration. The one that I'm playing with right at the moment is it's a band pass filter, and the band pass filter cuts off everything. I'm trying to get it to cut off everything below the 630 meter band, and then everything above the 630 meter band. So it's only giving me the through. It only lets through the frequencies for the 630 meter frequency. So anyway, and that's the little nano VNA that we featured on here in the past. The next thing that I thought I would show you is I had to do some repairs, some repairs on my Lindenblad antenna. Now this is this is one of two antennas. This is the left-hand circular polarized, and you'll notice that they all dip in a particular way, and you'll notice the right-hand circular polarized is in the other direction, the way that this particular antenna works is you've got your stock standard dipole, folded dipole at the frequency that we want, which is the 70 centimeter band, and each of these dipoles is exactly the same, and there's a bit of 300 ohm ribbon, television ribbon, that goes down. That's a particular length, the tuned length that we want, and they're all connected in a particular way to the end of a bazooka ballon. So it's a bit of brass tube that is in the bazooka ballon configuration, and at the top of that tube, all four of these are connected in exactly the same way. So these are little what we call phasing lines that all phase, make sure everything's together. And what this enables us to do is receive a signal, in this case a left-hand circular polarized signal at 70 centimeters, and I've been using these for satellite communications. So I've got one that's left-hand circular polarized and one that's right-hand circular polarized, and there's a coax switch between them up on the roof, and I can switch between them to get the best polarization I can find to receive the best signal from the satellite. I also use these as my main 70 centimeter antenna actually, and to good effect, because I can actually receive all over Hobart and beyond. And one of the big advantages of the Lindenblad antenna, and it's Lindenblad, that's the actual the creator of these particular antennas. And you'll see a lot of these antennas, this type of antenna, at airports. They don't necessarily have a folded dipole. They might just have a dipole with two equal segments out each side. But the big advantage of these antennas is they are very good at receiving really low angle radiation. And so that's one of the big advantages with these antennas. I've had satellite contacts where the prediction software is telling me that the satellite is well and truly over the horizon and I shouldn't be able to actually see it, but I'm still receiving a pretty good signal from them. So I put that down to these Lindenblad antennas. And they're all in a PVC tube. It's all celasticed up so that it's waterproof, and then the bit of coax comes out the bottom. I've got a little mounting clamp on the bottom, and I've labelled them left-hand circular polarised so I know which one's which. So when I plug it into the coax relay, it comes back to a little switch box that I can make sure that it is actually the left-hand circular one, not the right-hand circular one. So that's a Lindenblad antenna. I've used them for a long time. I do have all the bits for a 2 metre version of it, but have never quite got around to making it. But anyway, that's a Lindenblad antenna. Very good satellite, fixed satellite antenna. A fascinating little antenna arrangement, and well worth a bit of a look if you're looking for some fixed satellite antennas, not ones that you need to track, but fixed satellite antennas. Really does well. So that's now what I might do is I'll get Richard in, because we have done a whole lot of tests with our 3.4 gig antennas, and we actually did really well on the weekend. So I'll get Richard in to give us a bit of a report on the 3.4 gig. Just stand by. We'll head to our test pattern, and I'll go and get Richard. Come on, Richard. Come in. Come in. Close the door. Ken's back. VK7DY's back. Now, we're talking... good evening, Richard.
Good evening, Master Justin.
And Master Richard. It's a very cute mask.
It is very good. I'd love to get one of those LED ones. Have you seen them on? That would just be so cool.
Oh dear. Okay. Now, we're talking 3.4 gigs.
Ooh, 3.4 gigs.
Where is it? Oh, there it is. And in fact, I've got a little one.
Did I send you mine? Because I think I left my phone at the...
Oh, did you? Do you want to go and get it?
Yeah, I might. My mind.
Just hold that thought.
Time for a walk in Black Forest.
That's it. Now, what I'll do here is we'll zoom in on this. Now, we tried oh, God, blimey. Just when you think it's safe to go back in the kitchen, I do need to do a walk in the Black Forest, don't I? There we go. Now this is the 3.4 gig arrangement that I was using. You can see I was actually using the 705 in this case, which was good because I had a much better signal meter on the 705 than my handheld, which was a bit dodgy. But you can see there's someone being received at 5.9. It was probably you, Richard.
You had a colossal signal. I really just couldn't believe how loud it was.
Oh well, there you go.
I was super impressed. Now I sent you a photo of my
Whoops. I might have to edit that one out there, but anyway.
One of those photos that can't be unseen.
Yes, yeah. Very topical. Very topical in southern Tasmania right at the moment.
I think I might have actually sent it to you in the Book of Faces.
So this. Oh, okay. Do we need to go into the Book of Faces? So this is the South Hobart end. Now this is me actually looking at Mount Rumney. So this is in the other direction. So, and in fact, I realised now that was actually pointed sort of upwards, which would have probably been going over Mount Rumney. But anyway, you were receiving it. Now what we had was I was at South Hobart. Hayden was at Mount Nelson. Alan was at Blackman's Bay,
yep.
And you were at Tea Tree?
Yeah, that's right.
So, okay, I've had a long day. In fact, that's the one I used with the mask. It's on the advertising. You can see Mount Wellington in the background, so I am clearly not pointed at Mount Wellington.
No, that's true.
It's the big, yeah, and it's the big dish. That was the Lindenblad before.
I was looking for the one that I sent you, which had my setup, which was the large panel antenna.
Oh, maybe no, it was in the Discord session.
That's what I was just looking through that.
Yeah, that's exactly it.
Oh, well, that's the antenna there.
Oh, done.
Well,
Is that going to do the right thing?
yeah, maybe for a moment.
So this is the back of Richard's panel antenna, made in Israel. That's interesting.
They make all good electronic things.
RF things, definitely. Dual polarised antenna, 3.3 to 3.8 gigs.
It says DP25. I don't know whether that's maybe an indication of gain. Maybe
25 dB.
It's quite big. It's about 600 square.
Maybe.
I had to modify the bracket so that you could actually get the cables in because it was designed.
Oh no. And that's go up. That's Hayden. So
yes.
Just click on that because we can show Hayden set up here where he's actually gone to Mount Rumney. So this is from Mount Nelson at Mount Rumney. Now he did go to the front of the unit and he could actually see Mount Wellington.
Yep.
So there is a possibility that he may actually be able to set up at the front.
Because I was actually getting him via a sort of a double refraction because he was aiming at Mount Rumney and which was scattering off to Mount Wellington, which is where, because I got the best signal off Mount Wellington.
Off Mount Wellington.
Like
yeah,
no matter
yeah.
what. So.
Yep. Oh,
Yeah.
that was our polarisation discussion.
That's right. So,
and in fact, that's 4CZ's arrangement.
Yeah.
Just click on that because that's
I don't know whether it'll.
That's not bad. This is. I assume they're all on different bands.
I think 2.4, 3.4, and 5.7. I think.
Whoa. Okay. This is VK4CZ's arrangement, QTH arrangement on VHF and above. So
nice.
very impressive. Very impressive.
That looks like
indeed.
1296 get to the very top.
So anyway, that's our quite successful. Mount Rumney, I think, was a bit of a sort of a compromise for all of us.
I think the problem we've got is that by having these antennas with lots of gain, we're sort of reaping the rewards of the gain tree, but we're sort of being stitched up a bit because you've got to aim at the right rock on the mountain.
Correct. That big grid pack is quite sharp. It's quite sharp when you turn it around.
Well, that's obviously where the 27 dB gain is coming from. So
well and truly. But good. We now have 4 on 9.
Well, we've got 2 more on the way.
So there's 6.
So our aim is 9 on 9.
So, and we do have, because I noticed Murray's 3.4 gig panel out there.
Well, I've still got my original Gark panel that's been modified
Correct.
and put in a thing, and I want to try and spend some time with that because that could be another opportunity.
I was thinking the same thing, and now that I've actually got something that I can refer to as a reference, so 3.4 gigs is exploding in VK7.
Yeah.
So, and have you been doing anything exciting over the
Not really exciting.
last week?
Trying to finish off some things. I've been trying to finish off this dreaded 1.8 metre dish tracking project. I was nearly ready to, because I want to finish it so I can pull it apart and paint it.
Oh, okay. Yes.
And I did some tests the other day, and it had a moment, and like we'd had the discussion the other day about, or just early on today about the rotation. There's quite a deal of science in the way that the software keeps track of rotation. It
Correct.
actually works on a 720 degree rotation, so you don't wind up cables. And
Correct.
it's also tied up to, with the incremental encoders, that you've got that Z pulse.
Yes. Yeah.
And of course, they always sort of recommend, you should put the encoder in a position where the Z pulse
Yep.
is a heading that's crossed regularly, and they recommend, like say north, or,
Yeah. Okay.
maybe the northern hemisphere you'd have it south. So
Yeah. Okay.
So we might have a play later, but I wanted to try and actually get one of the encoders and actually set it up with some voltage and turn it and watch it on maybe on a crow.
Okay.
And actually see when the Z pulse occurs.
Yeah. Okay.
So then you can maybe mark it on the thing, so you can actually physically turn your dish around and go, well, okay. Because yours is a little bit like mine. It's a portable. You really need to be able to have it orientated with an arrow that you can say, right, when you set it up, pull it out of the car and drop it on the ground,
Pointed in this
roughly
direction.
aim that sort of north.
Yeah.
So then, as long as you're within a few degrees, it should be okay. So.
Okay.
But that's because I want to just finish the damn thing, so I can put paint on it, then I can.
We
I
can
can
have it
use
at the revised open day.
Yeah. Because I've got the Minikits ordered some attenuators, so
Okay.
that'll be for the SSPA. So
Excellent.
that'd be really nice to have it just finished.
Very good.
Can't wait.
Very good indeed.
Then we'll start the next project.
3.4 gigs. Oh dear, oh dear. And how's that 2.4 metre dish going?
2.4 is still laying behind the container, but that's I'm thinking 3.4 gigs would be really nice to put a feed in that.
You could definitely do moon bounce with that.
I've been spent a bit of time looking at Charlie VK3 and Nexus.
Yep.
He's got an awesome setup over there. He's got a 3.7, one of those
Wow.
RF hand designed dishes.
Okay. That's a big dish.
It is a big dish, and I think he's done EME on everything from 6 metres to 24 gigs. Not on that dish, of course, but
Okay.
3.4. I think he's got the 3.7 metre dish, and I think he runs those Toshiba amps, the two
Okay.
583As. I think he's got 2 of them together and gets about 100 watts.
Okay. Okay.
So hopefully I can muster 50 watts. Getting the preamps, again, because 3.4 gigs has sort of disappeared off a lot of places,
Correct.
the market of preamps and things is
It's drying up.
dried up. But I believe our friends at Down East Microwave still, so I'll probably be sending
Correct.
sending an order off to them.
And they are great little kits, and their kits, the Down East Microwave stuff. I've done three and a half, 4 kits from them, and they just work. Like,
I was a little bit
no
had some
mucking
reservations about, I don't have the test gear to be able to you see some fairly impressive testing done by
correct.
people. But
well and truly. And you see their test bench and you go, wow, okay, that's a 22 gig spec hand. That's a this, that's a that.
But look, I think it's worth. And look, I think if we're going to sort of do it, it'll be really cool. Like I think with 50 watts in a 2.4 metre dish, it could probably work down.
That would be well and truly.
Like dance. I'm sure you love it. But,
Well and truly.
but
Be the first 3.4 EME contact in VK7.
in VK7, yes. I don't think Rex has
Oh,
done it as yet.
Everybody will jump on you.
So, yeah. It's like being Rare DX, eh?
Rare DX off the moon. I love it. I love it.
In fact, Dan said that once on one of the things when there was Rex was at his place working and I was at my place working, and he's come back on the logger and he's gone, really? He goes, a pile up on the moon from VK.
VK7s. Yeah.
Well, there was VK3NX and there was a couple other guys as well. Right? It's like, really?
I love it. I love the humour. It's very good.
That's good. No, look, it's
very good. All right. Thank you, Richard.
that's good, all right.
That is fantastic. Now, we just a quick reminder before we disappear. We're already at an hour. I can't believe that. I don't know where that went. It might have been the Chladni plate that I might play with a little bit more because it has totally different characteristics with dust. So just a reminder, our November presentation night, which is all about digital hotspots, with Scott VK7HSE, is on November the 3rd, up here, 7:30 PM. Now we haven't got a revised date for the postponed open day, but watch this space. Once we have a revised date, we'll go out with advertising on all of the various channels that we now advertise on. So. Which seem to be multiplying, so at a great rate. So we'll get that underway, and the videos for our RF viewers. The first one I'm very fond of because it's Professor Julius Sumner Miller talking about resonance. So I thought I'd include that one. But there's also one on sympathetic resonance, a demonstration of resonance, and also an interesting one which is a better description of resonance. So there's somebody who's put a bit of thought, Steve Malt, put a bit of thought into it. So anyway, that's our presentation night for the 20th of October. I can't believe it is the 20th of October. It's show day tomorrow down here, so it is a public holiday. So definitely. So definitely looking forward to that, and it's my birthday.
Oh, happy.
So I get the day off. I get the day off tomorrow. I get that about every 3 or 4 years. So excellent. All right, that's our DATV night for the 20th of October. Thank you, Richard.
Thank you, Justin.
And we'll have all about RF resonance next week. So you don't have to put up with very loud, high frequency noises anymore from me, because we'll be way up the spectrum into the RF spectrum. So there you go. Anyway, have a fantastic week. Stay safe out there, and we'll catch you next time. 73.
73.